Okay, so today we're going deep into a conversation that Kesser had. It was at a garden center. And
A garden center.
yeah,
Interesting. Okay.
yeah. And our sources tell us he was talking with a man in a green shirt, and it got pretty interesting about the way
I love it.
plants and soil interact. I think this is something a lot of our listeners can relate to.
Absolutely. It's one of those everyday things that you might not think twice about. But once you start digging into it, it's just fascinating, like what's going on beneath the surface.
Exactly. And Kessler had a specific question. You know, he wasn't just there for the petunias. He was wondering if he could improve the soil under his apple tree naturally. Like, could he skip the artificial fertilizers and do it a different way?
That's a great question.
Hmm.
We've talked about fertilizers before and how they can be helpful, but also how they can sometimes have unintended consequences. So
Hmm.
I'm curious, what was he thinking?
Well, it sounds like he was thinking about using plants like companion planting to create a healthier environment for the tree. And the real kicker is he even thought about doing some at-home experiments to see how it all works.
Wow, that's impressive. So he's not just asking questions. He's actually thinking about how to test things out for himself. That's the scientific method in action.
Right. So before we even get to the man in the green shirt, let's talk about what Kesser was already thinking. He had this idea about root exudates and how they might be the key. Have you ever heard of those?
Oh yeah, root exudates are super interesting. They're basically these compounds that plants release from their roots into the soil. And it's not just random stuff. It's a whole mix of sugars, organic acids, amino acids, all kinds of things.
Like they're talking to the soil, right?
Exactly. It's like their own little language.
Yeah.
And what's cool is these exudates can do all sorts of things. They can attract beneficial microbes, fend off harmful ones, even change the soil chemistry a bit. Plants are way more active than we give them credit for.
That's so cool. So Kesser was thinking about all this as he was looking for plants to put under his apple tree, and he wanted to find something that would help the soil be healthier. Plus, if he could reduce or even eliminate artificial fertilizers, that would be a huge bonus.
I can see where he's coming from. It's all about finding those natural solutions that work with nature, not against it. And less fertilizer also means less risk of runoff and those negative impacts on waterways and ecosystems.
Absolutely. So did he have any specific plants in mind?
Well, he was really interested in legumes, like clover. He knew they were nitrogen fixing and had a feeling they might be able to, and I love this phrase he used, reduce the soil in a way that would be good for the apple tree and keep diseases away.
Okay, reduce the soil? What does that even mean?
Yeah, that's where the man in the green shirt comes in. He was kind of like a walking plant encyclopedia.
Oh.
He explained that when Kesser talks about reducing the soil, he's actually talking about redox potential. It's a bit of a chemistry term, but basically it's about the balance of oxidation and reduction happening in the soil. And that balance, that redox potential, really affects how nutrients are available and how those microscopic creatures, the microbes, are doing down there.
This is blowing my mind. So Kesser was onto something with his reduce idea, even if he didn't know the exact scientific term for it.
It's like he intuitively understood there was something important going on there. And that's what's so great about this whole story. It shows that you don't have to be a scientist to have these insights and ask these important questions.
So what did the man in the green shirt have to say about all this? Did he think Kesser was on the right track?
He did. He basically said Kesser was onto something really cutting edge, like on the frontier of research in plant-soil microbiome interactions.
Wait, what? Say that again?
Microbiome. It's kind of a buzzword these days, but it basically refers to all the microscopic organisms, bacteria, fungi, and others living in a particular environment. And in this case, we're talking about the soil microbiome, which is incredibly diverse and plays a huge role in soil health and plant growth.
Okay, that makes sense. So the man in the green shirt was basically saying, hey, you're asking all the right questions. This is the stuff scientists are really excited about right now.
Exactly. And he went on to explain in more detail about those root exudates, those sugars, acids, and other compounds. He said some of them act like signals to the soil microbes, almost like the plant is saying, hey, come over here, there's food, or watch out, danger zone.
Wow, it's like they're manipulating their environment.
They are. And then he went back to the legumes, confirming what Kesser had guessed. Legumes, like that clover, are amazing because they have this partnership with special bacteria called rhizobium. And those bacteria can do something incredible. They can take nitrogen from the air, which plants can't use directly, and convert it into a form that plants can absorb. It's like they have their own little fertilizer factory right in their roots.
I remember learning about that in school, but it's amazing to think about it happening right there in your garden.
Right. And there's another twist to this. When the rhizobium are doing their nitrogen-fixing magic, they actually make the soil a bit more alkaline. And that shift in pH can actually make it harder for some of the bad guys, those disease-causing pathogens, to survive. It's like a natural defense mechanism for the plants.
This is making me want to run out and plant clover everywhere.
Well, hold on. There's always a balance, right? Too much of a good thing can sometimes backfire, but we'll get to that in a minute. First, let's talk about the specific plants the man in the green shirt recommended for under the apple tree.
Okay, what did he suggest?
So first up was white clover, Crofolium repens. It's that common clover you see in lawns and meadows. He was a big fan of it for a bunch of reasons.
Yeah, like what?
Well, like we said, it's a nitrogen fixer, which means it's helping fertilize the soil naturally. That's a win for the apple tree.
And it can handle some shade, right? Which is important since it's going under a tree.
Yep. And it's good at holding on to moisture, which can be a big help in dry conditions. Plus, it's slow growing, so it acts like a living mulch, suppressing weeds and protecting the soil from erosion.
I'm already sold on clover. Anything else?
Well, even if it doesn't flower as much in the shade, it can still be a good food source for bees, so that's another bonus.
That's awesome. So clover's a go. What was next on the list?
The next plant he suggested was a bit more, shall we say, dramatic? Foxglove, Digitalis purpurea.
Oh, I love foxgloves. Those tall spires of flowers are so pretty.
They are stunning. But unlike clover, foxglove isn't a nitrogen fixer, and it doesn't release tons of sugary exudates to feed the microbes. It's got a different game plan.
So what's its special talent?
Well, foxglove contains some pretty potent compounds, most notably something called digitalis glycosides.
I think I've heard of those. Aren't they used in medicine?
Yeah, they can be, but they're also pretty powerful, so it's not something to mess around with. The point is, the man in the green shirt suggested that foxglove might actually release some of these compounds through its roots, which could have antimicrobial effects in the soil.
Antimicrobial, you mean like killing off bad bacteria and fungi?
Exactly. It's like foxglove has its own built-in defense system. Now, how much of an impact this has in a garden setting is still up for debate, but it's definitely an intriguing possibility.
So foxglove might be like a bodyguard for the apple tree's roots.
In a way, yeah. He also mentioned that foxglove tends to like brighter, more open areas, so it might not thrive in deep shade.
Okay, that makes sense. So it might not be the perfect underplanting for every apple tree.
Right. He even suggested that if you plant foxglove and it starts to struggle, it could be a sign that the apple tree is casting too much shade. It's like a natural light meter.
I love that. So we've got clover for soil health and foxglove for potential disease control and shade indication. Sounds like a good combo.
It does. And the man in the green shirt actually recommended a combined planting strategy using both of them.
So how would that work exactly?
Well, he said to use white clover as the main ground cover, kind of like a living carpet under the apple tree. That would be the workhorse for improving the soil and providing that slow-release nitrogen.
And the foxglove.
He said to add in patches of foxglove here and there, just for visual interest and for the pollinators.
Because bumblebees love those foxglove flowers, right?
They do. It's like a bumblebee buffet. And having both plants means you've got something flowering at different times, which is always good for the bees.
This is all so smart. I'm learning so much.
Me too. And this is where the story gets even more fun. Remember how we said Kesser was thinking about doing some experiments?
Yeah.
Well, he has a school friend named Steen, and they have a little garage laboratory where they like to tinker and test things out.
I love these guys already.
Me too. And they were both super excited about the idea of using clover and foxglove under the apple tree.
Wait, so they were going to actually try this out in real life?
Yeah, they were all about it. Kesser even said that Steen was especially keen on the foxglove because of the bumblebees. He thought it would make the garden more magical.
Oh, that's so sweet. I wonder if he has a little bee costume.
Maybe. So, anyway, the man in the green shirt, bless his heart, he really embraced their enthusiasm and even started brainstorming some low-tech soil testing methods they could use in their garage lab.
No way. He was that into it.
Oh, yeah. He was all in. He suggested they build these little galvanic cells, basically just copper and iron rods connected to a voltmeter to measure the redox potential, which we talked about earlier.
Wow. So like a DIY science project?
Totally.
Okay.
He said it wouldn't be super precise, but it would definitely show if the soil was becoming more oxidized or reduced over time.
I bet Steen was all over that.
Oh, for sure. Then he had another great idea for testing microbial activity. He said they could bury little bags of cotton or natural fibers in the soil and see how quickly they decompose.
Okay, wait. Explain that one to me. How does that tell you about microbes?
So the microbes in the soil are the ones breaking down those fibers. The faster the decomposition, the more active the microbial community. It's a simple but effective way to get a sense of how alive the soil is.
That's brilliant in its simplicity. I am so trying this. What else did he come up with?
Well, for moisture, he suggested using unglazed clay pots, like those terracotta pots. You bury them in the soil, fill them with water, and see how fast the water level drops.
That's clever. So if the water level drops quickly, it means the soil is drying out fast.
Exactly. And if it stays pretty stable, it means the soil is holding on to moisture well.
I'm loving these low-tech solutions.
Me too. They're so accessible. And finally, he recommended using those cheap pH strips to track any changes in the soil's acidity or alkalinity, especially to see how the clover might be influencing that.
So they've got all these tools for monitoring their experiment. Did they have a plan?
Oh, yeah. He helped them design a little experiment with different areas under the apple tree, one with just clover, one with nothing special, and maybe one with both clover and foxglove. That way they could compare what happens in each spot.
So cool. Did they actually keep track of all their findings?
They did. Well, they were planning to. The man in the green shirt even offered to help them make a little logbook, like a garage protocol, as he called it. They could write down their observations, their measurements, all that good stuff.
That's dedication.
It is. And it reminded Kesser of a funny story about losing a sock during a previous experiment they did in the woods.
Wait, they lost a sock in the woods.
Apparently, they were doing something called a micro-life harvest, and somehow a sock went missing. I guess things can get a little chaotic in the garage lab.
That's hilarious.
It is. And you know what? That reminded them that they should probably put out a little dish of water under the apple tree for the wildlife. Just a small thing, but it could make a big difference for thirsty creatures.
I love that idea. So they're thinking about the big picture too, not just the plants, but the whole ecosystem.
Exactly. And Kesser, always the curious one, wanted to double-check the science behind the whole alkaline effect of the nitrogen fixation. He asked if it was because the ammonium, that form of nitrogen the rhizobium make, was reacting with hydroxide ions in the soil, and the man in the green shirt confirmed that he was spot on.
Wow, so they're really diving deep into the chemistry here.
They are, and the man in the green shirt was amazing. He even grabbed a scrap of paper and sketched out a sample logbook page for them with columns for all their measurements and observations. Talk about going above and beyond.
I bet they were over the moon with excitement.
They were. Kesser even started dreaming bigger, talking about getting a wildlife camera to film all the action under the apple tree. He even joked about Steen wanting to camp out there to watch everything firsthand.
That's too funny. And it would be amazing footage seeing all those little creatures coming and going.
Right. And the man in the green shirt loved the idea. He even suggested some affordable cameras they could use that wouldn't disturb the animals.
So they could have their own little mini wilderness observatory right in their backyard.
Exactly. And imagine combining the camera footage with their logbook entries. It would be like having a whole natural history documentary in the making.
That would be incredible.
Right. And he told them, hey, this could even be a school project. Imagine presenting this to your class.
Oh, that would be so cool.
I know. So he even offered to help them design an overview, like a big poster, where they could put in pictures and their notes.
This man deserves a medal for his dedication to these kids.
He really does. And then, just when you thought it couldn't get any better, Kesser pipes up and says, glue is old school. Steen wants an app for this.
An app?
Yeah. Kesser was all about the modern approach. He was like, forget the paper logbook. We need an app to track all this data.
Of course he did. Kids these days.
And you know what? The man in the green shirt didn't miss a beat. He was like, an app? Great idea. He immediately started brainstorming features, a place to upload photos, record the date, the pH, the moisture levels, even that missing sock data.
Missing sock data.
He was joking, I think. But he was really into the idea of an app. He even said, let's start with a simple prototype, and then we can add more complex features later, like graphs and stuff.
Wow, he's like a tech wizard, too.
I know. He even offered to create a basic code prototype for them using JavaScript or Python.
Seriously, this man is a saint.
He really is.
Yeah.
So you've got these two kids, Kesser and Steen, totally pumped about their apple tree experiment, armed with all this knowledge and support. And just when you think they're done, Kesser throws out another curveball. He says, hey, I'm also planting a flower meadow. Any tips on where I can find info about how those plants interact with the soil?
He's on a roll now.
He is. And the man in the green shirt was so honest, he said, you know, there's not one single place that has all that information. It often takes some digging and research to find what you need.
I bet Kasser was a little disappointed.
Maybe, but he didn't let that stop him. And true to form, the man in the green shirt offered to help, saying, "I can put together a starting list of plants for you, with notes on what we know about their effects on the soil."
That's amazing. He's like their personal plant consultant.
He really is. And finally, Kesser had one last very important request. He asked the man in the green shirt to draw a logo for their wilderness observatory, something Steen could put on his cap or backpack.
Oh, I love that. They're taking their mission seriously.
I know, it's so inspiring. So there you have it. A chance encounter at a garden center turns into a whirlwind of knowledge, experiments, and a whole lot of heart.
It's a great story. It just goes to show that the most amazing discoveries can happen in the most unexpected places.
Absolutely. And it reminds us that even simple questions can lead to profound insights about the natural world.
So what's the takeaway for our listeners? What can they learn from Kesser and Steen's adventure?
I think it's a reminder that we can all be citizen scientists. We can all ask questions, observe, experiment, and learn more about the amazing web of life around us.
And we don't need fancy labs or expensive equipment to do it. A little curiosity and a willingness to get our hands dirty can go a long way.
Absolutely. And as Kesser and Steen's story shows, there are people out there who are passionate about sharing their knowledge and inspiring others. So don't be afraid to ask questions, connect with others, and explore the natural world around you.
I couldn't have said it better myself. So for our listeners, I have one final challenge for you. Take a moment to think about your own garden or your local park. What questions do you have about the plants and the soil? What simple experiments could you do to learn more?
Maybe you could try burying a sock in the woods and see what happens. Just kidding. But seriously, channel your inner Kesser and Steen and see what you discover.
That's it for this deep dive. We'll see you next time for another fascinating journey into the world around us.
Until then, happy exploring.
Okay, so today we're going deep into a conversation that Kesser had. It was at a garden center.